Good morning, Assalamu alaikum. This is the Life School Nushara campus. It's our chemistry class for 10th. Today's topic is classification of organic compounds, page number 54. And here we are. So, organic compounds are classified into two main branches, and they are saturated organic compounds and unsaturated organic compounds. Saturated organic compounds are those organic compounds in which each carbon atom in the molecule forms 4 single covalent bonds with other atoms. What does it mean? It means that carbon atom would make at least 4 covalent bonds with other atoms. They may be carbon, they may not be carbon, right? If you observe here, all of these bonds are single bonded, so we can say that saturated organic compounds are those compounds in which the carbon atom is singly bonded with other atoms. Singly bonded means a single covalent bond is present among them. So in this case, this is methane, that is CH4. If we take another case, that is of ethane, so what is over here? 2 carbon atoms are bonded, but for saturated organic compound, what's the condition? The condition is that each carbon atom would be attached to 4 other atoms. So let's take them as hydrogen, 1, 2, 3 and 4th is with carbon, and in this case hydrogen and hydrogen. So what is it? This is C2H 1, 2, 3, 4, 5, 6. That's ethane, right? We can also take another example, that's of ethanol. Let's take it as carbon is bonded with another carbon. In this case, there are 3 hydrogen atoms. So CH3, 1, 2, 3, 4, carbon is bonded with other 4 atoms. Now in this case, what will happen? That there would be 2 hydrogens, and what would be? Hydroxide or hydroxyl group, right? So same is the case again. 1, 2, 3, 4. There are 4 bonds made by this carbon, 4 bonds made by this carbon. So saturated organic compounds are those compounds in which carbon atom in the molecule forms 4 single covalent bonds with other atoms. These atoms may be carbons, these atoms may be other atoms or molecules as well, right? Okay. Now, all of the saturated carbon atoms are called as alkenes, right? Okay. Coming towards unsaturated carbon atoms. So what are unsaturated organic compounds? They are those compounds in which carbon atom is attached to other atoms by a double bond or by triple bond. So this means that these unsaturated compounds are divided into 2 main groups. Number 1, in those compounds which are making double bonds, at least 1 double bond would be present in these molecules, whereas those molecules which are in which the carbon is bonded with other atoms by at least 1 triple bond. So where there are double bonds, they are known as alkenes, and where there is a triple bond, they are known as alkynes, right? Let's take an example of double bond. So here in the ethane, just take as ethane, that is CH3CH3, right? that will happen now here. There is a single bond and CH3. In this case, all of them are single bonds, right? Except these single bonds, the other condition, which is that is carbon is making 4 bonds. This means they are alkane. But what will happen, that if I want a double bond over here, I have to remove this hydrogen from this side, and I have to remove hydrogen from this side as well. So what would be the case? That is CH2, a double bond, CH2. So now look over here, carbon is making a double bond over here. So it's very important. You would be thinking that why I have removed both the hydrogen from both sides, right? So the removal of hydrogen atoms was important. Why was that? That was because carbon has to make 4 bonds, because carbon has a valency of 4 plus 4, right? So in this case, carbon has to make 4 bonds. So bond number 1, bond number 2, bond number 3, bond number 4. But now if it's going to make 4 bonds, then we have to remove the third hydrogen, that is carbon bond number 1, bond number 2, bond number 3, and bond number 4. Same is the case with carbon 2, that is bond 1, bond 2, bond 3, bond 4. So there is at least one double bond among 2 carbon atoms. So we call such atoms as alkenes. Now what is the case with alkynes? Just look over here. Again, carbon has to make 4 bonds, but in alkynes there would be a triple bond. So obviously I have to remove this hydrogen. So I would get CH and a triple bond here, CH2. So now count these bonds, 1, 2, 3, 4, 5. Oh, we don't want this 4th hydrogen as well. So our molecule would become as C triple bond C, 1 hydrogen on this side, 1 hydrogen with this carbon. So carbon has made 4 bonds, and at least there is 1 triple bond in them, right? So in this case it was alkane. Here is alkene, not here. That was alkene's formula is CH2, right? CH2. And in alkynes there would be triple bond, so that is your alkyne, or you can say it's ethyne. Here it was ethene, and in this case it was ethane, right? Where is the difference? The difference is, number 1, if you look at the structure, so the difference is in the bond structures, and number 2, the difference is in the naming, the last 3 letters, in, and ein, remaining everything the same. So from here you got to know that organic compounds are divided into 2 main groups, saturated organic compounds and unsaturated compounds, on the basis of their bonding. If the bond is single bond among them, that would be alkanes. If the bond is double, that would be alkene, and if they are triple bonds, they will be alkyne. The double and triple bond organic compounds are called as unsaturated organic compounds, whereas the single covalent bonded compounds are called as saturated organic compounds, right? Now coming towards the another classification. The other classification of organic compounds is on the basis of carbon skeleton, or on the basis of carbon structure. Number 1 is open chain compounds, and other is closed chain compounds. So as the word suggests, in open chain compounds there would be quite long chain. Just take an example of propane. So what happened with propane? There were 3 carbons, right? There are 3 carbons, and each carbon is bonded with 3 hydrogen atoms. Right? Okay, so that is, this carbon is making 1 2 3 4 bonds, 1 2 3 4 bonds, 1 2 3 4 bonds. I'm not writing these hydrogens, but you don't have to be confused. There are, the hydrogens are automatically present, right? Okay, so it is an open chain compound, but when I write it in a closed format, how would be it? That is, carbon is bonded with carbon, and both of these carbons are bonded with another carbon, right? So in this case, the structure is in a closed ring. So as we said, carbon has to make 4 bonds. So 1 2, and there would be 2 hydrogens. 1 2, there would be 2 hydrogens, and 1 2, there would be 2 hydrogens, right? So look at the structure. The structure is now changed. What's the structure? It's a closed chain, and in this case, this is an open chain organic compound. Here we would say that it's a propane, whereas in this case we would say that this is cyclopropane, right? Here will be another difference. If you notice, the first carbon is attached with 3 hydrogen atoms, whereas in this case all the carbons are attached with only 2 hydrogens, whereas in propane, first and the last carbons were attached with 3 hydrogen atoms. So open chain organic compounds are those compounds in which carbon atom makes a long chain or a long structure, right? Whereas a closed chain compound means that in which, or those organic compounds in which the carbon atoms are linked together to form a closed ring or a closed chain, right? Now if you look here, open chain compounds are then further classified into 2 main compounds: straight chain and branched chain compounds. So straight chain compounds, just take the example of butane. In butane there are 4 carbon atoms, and again all these carbon atoms are attached with hydrogens. So this is what it is, butane. As this is composed of straight chain, we would say that is normal butane and butane, right? What is in the case of branch chain? In the branch chain, just think that we have a propane, CH3, CH2, CH3. And now from somewhere I want to attach CH3 with it. So where I could attach it, I would remove 1 hydrogen from here. So if I remove 1 hydrogen from here, it would be left as only 1 hydrogen, and the other hydrogen has been removed. So now let's count the bonds made by carbon. In this case, 1 2 3 4, right? 1 2 3 hydrogens here, and 4th bond, it's okay. In this case, 1 bond is here, 1 bond is here, 1 bond is with hydrogen. Now I can, all of them are 3, so I can attach this carbon over here, right? And as this carbon has to make 4 bonds, so there would be CH3, 3 bonds with hydrogen and 1 is with it. Now if we again count all the carbon atoms, so 1 2 3 and 4 carbon atoms here, 1 2 3 4 carbon atoms here. But what's the difference? The difference is that this is a normal straight chain organic compound, so it's N-butane, whereas 4 carbons are here, so now it's not propane, but it would be butane. But which butane is it? It's a branched butane. So branched butane is known as isobutane. Right? Done? Okay. Coming towards your other group, that is closed chain organic compounds. Closed chain organic compounds are being discussed here just like cyclopropane, but in this case there are 2 main types: alicyclic compounds and aromatic compounds. Alright, so what alicyclic compounds and aromatic compounds are? Just look over here to the straight chain, that is butane. In butane there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. But what if I make a cyclic structure of butane? 1, 2, 3, 4. Now, as I know, carbon has to make how many bonds? 4 bonds. So this means that there would be CH2. So 2 bonds here and 2 bonds here. In this case, there are CH2. There would be also CH2, and here would be CH2, right? Whereas if you look at N-butane, normal butane, this is cyclic butane. It's normal butane. In normal butane, first carbon was having CH3. So there were 3 hydrogen, then 2 hydrogen, then 2 hydrogen, and then 3 hydrogen. Altogether 3, 4, 5, 6, 7, 8, 9, 10. And here altogether 2, 3, 4, 5, 6, 7, 8. So you can say that in the structure of straight chain butane and alicyclic butane, what's the difference? The difference is, number one, the difference is that it's straight and it's ranked form, right? Number two, their formulae are different. Number three, it is having, straight chain is having 2 more hydrogens than alicyclic compound, whereas alicyclic compound is having 2 hydrogen atoms less than normal butane, right? Not only in butane but in other cases as well. So these cases where the carbon atoms are attached with single bonds, they are called as alicyclic. But in that case, when carbon atoms are attached by a double and single bond, alternative double and single bond, then we call them as aromatic compounds. Just take the example of a benzene ring, if you remember. That is benzene ring, 6 carbon atoms are attached, just like this. Now, which carbon, which type is it? Look here, all of them are attached with single bonds. I don't have to make but you should know that there is CH2. There would be CH2, there would be CH2, there would be CH2, here is a CH2, here is a CH2. Why is that? That's to fulfill the capacity of carbon bonding, right? So 2, 3, 4, 2, 3, 4, 2, 3, 4, all of them. So how many carbons are here? 1, 2, 3, 4, 5, 6. So I can say it is a cyclohexane. In which compound is it, alicyclic or aromatic? I would suggest that this is alicyclic compound. Why? Because all of them are bonded by single bonds. Whereas in aromatic, what happens? Just take the same compound. But in aromatic case, what happens? If there is a single bond, then there would be a double bond. That is the case of single, then double, single, double. So these type of bonding, single, double, single, double, single, double, are called as alternate, right? Alternate single and double bonds. So those carbon organic compounds which have alternate single and double bonds in their structure, we call them as aromatic organic compounds. And their starting aromatic compound is benzene ring, right? So it was enough for you all, and what you have to do, you have to read from page number 54 to page number 56. There's another type as well, homocyclic and heterocyclic, but right now do not go in that detail. We will discuss them later. Till now, what you have to think over saturated and unsaturated compounds. You have to think over open chain and closed chain compounds. You have to think over straight chain and branch chain compounds, and you have to think over alicyclic and aromatic compounds. That was enough for today. Hopefully you understood well, but wherever you find any difficulty, please feel free to ask. Thank you very much. Stay home, stay safe. Bye bye.